better. So we were given the assignment of creating a video identifying a concrete law of physics. So today we're going to talk about projectile motion. Projectile motion is extension to the two dimensions of freefall motion, making it so that a projectile moves along a curved path when thrown near or at the Earth's surface, under the influence of gravity and nothing else. The horizontal and vertical components of an object undergoing projectile motion are independent of each other, creating vertical and horizontal velocity and acceleration. The vertical component of acceleration for all projectile motion is 9.8 meters per second squared, going in the downward direction, while the horizontal component is 0. So in our experiment, we recorded the motion of a tossed ball with a total of 3 throws, all at different distances, short, medium, and long, to compare the effect of gravity and freefall motion on the different calculated velocities. We did this by recording its distance, time, and launch angle. For the first toss, we had the values of 1.28 seconds, around 2.6 meters or 8 feet 5 inches, and a launch angle of 40 degrees. This gives us our known and unknown values. Plugging in our values from the first toss of the experiment, we got a horizontal velocity of 2 meters per second, an initial velocity of 2.61 meters per second, and a vertical velocity of 1.68 meters per second.
This projectile was launched a little bit further than the others to show which values are affected by distance and time in projectile motion. The ball was thrown at about 3.56 meters, and I predicted that the ball would show a significantly larger velocity because it fell over a larger distance. And I created a motion graph using a software to track the motion of the ball. Even though I predicted that the ball would have a relatively larger velocity than the other calculations, the ball traveled at a relatively similar velocity to that of the other times. This can be explained as the only force of acceleration acting on the ball is gravity.
Our third test was the shortest, being thrown a length of 1.876 meters or 6.17 feet. Starting off, we have our known values on the left and our unknown values on the right that we solved for using our known values. The final horizontal velocity was similar to that of test 1 and 2, yet our final vertical velocities was different for all 3 tests. The final velocities for test 3 was 2.8999 meters per second for our horizontal velocity and 2.1014 meters per second for our vertical velocity.
These were the final values, or the calculated velocities, of our experiment. But what do they show us in their comparison? As seen in these graphs that compare the x velocities and y positions of all 3 tosses, all values are close to each other, going against our original prediction that larger distances would have a much larger velocity. This is due to the single force acting on a projectile, gravity. This leaves us with our final statement. With the definition of projectile motion, we can conclude that the projectile in our experiment followed similar paths due to the single force acting upon it when thrown, the force of gravity. With this, we were able to complete the goal of our experiment, to determine the parameters affecting the motion of the object in freefall after being launched.